Hello everyone, my name is Devashish Roy. I'm the Senior Network Analyst at the Indian Cybersecurity Solutions. And today I welcome you all to this webinar. And the topic for today is securing WAN links with Cisco DMVPN, that is a dynamic multi-point VPN and FlexVPN. So we discussed earlier about the VPN, GRE tunnel and IPsec VPN in general. Today we'll discuss specifically about the dynamic multi-point VPN technologies and FlexVPN. So let's begin with the overview. So we'll discuss about the strategies for securing WAN links using Cisco's DMVPN and FlexVPN technologies here. So what is the overview of WAN security? How can you secure the WAN protocols to the WAN links? Securing WAN links is very critical to protect sensitive data is also becoming essential part now. Now, unauthorized access and data breaches can significantly lead to financial loss and damage to an organization reputation. So you have to make a very secure infrastructure in place. So what are the common threats to WAN security? The WAN security faces several threats include data interception, man-in-the-middle attack, denial of service or DOS attacks. All these may exploit vulnerabilities in the network infrastructure or endpoints to gain unauthorized access. So you have to understand these threats in order to mitigate those. Now, what is the role of encryption in WAN security? Now, encryption plays a vital role in WAN security by ensuring that data sent over the network is only accessible to authorized parties. So only the authorized person can access the data. No data breach can happen. Some unauthorized access or hacking the data cannot take place. Technologies like the IPsec VPNs and SSL TLS, they secure data in transit. So these are the protocols to secure the data. And the implementation of strong encryption protocols can significantly reduce the risk of data compromise and data security breach. Now, let's understand what is the role of the DMVPN here. What is DMVPN? Dynamic Multipoint VPN or DMVPN is a technology which is designed by whom? By the Cisco itself. And it is for the scalable and flexible WAN connectivity. Now, it allows multiple remote sites to connect securely to the central site. So it is using a hub and spoke architecture. Hub and spoke design means that central hub is at the center and other spokes are in like the satellites, that they are the clients, they are the spokes, while minimizing the complexity of configuration and management. Now, what are the key features of DMVPN? DMVPN supports dynamic IP addressing, means IP addresses are allocated dynamically or dissolved or mapped dynamically, allowing remote sites to connect without pre-configured IP address. So the main thing is that DMVPN, it actually communicates without the hub, because in case of the normal VPN, all the connection goes through the hub router and it takes a lot of delays, so the latency increases. But in case of DMVPN, the clients can communicate directly without the intervention of the hub router. It also utilizes multi-point GRE tunnels and NHRP, next hop resolution protocol, that is for efficient routing and path selection. So definitely GRE tunnels should be there, but it won't be the point-to-point, it will be point-to-multipoint, enabling seamless communication between the sites. And what about the FlexVPN? Now, FlexVPN is Cisco's next generation VPN technology, actually, that provides secure and flexible connectivity tailored for varying network requirements. And it's a combination of the prior VPN technologies, means a traditional technology, while introducing a more modular and scalable solution. Now, FlexVPN leverages the strength of IPsec protocol and IKE version 2, Internet Key Exchange, IKE version 2, for robust security and efficient key management, and it makes it suitable for both remote access and site-to-site VPN configuration. So it is also like the another VPN solution that you are having, like the DMVPN. Key components of FlexVPN include several essential components, including IPsec for data encryption, IKEv2 for secure key exchange, and various protocols such as NHRP for dynamic address resolution. Additionally, FlexVPN supports multiple authentication protocols and methods, and it ensures a secure connection, and it can adapt to the different security policies as well. What are the advantages of FlexVPN over traditional VPN? Like the FlexVPN offers several advantages, like allowing organizations to easily add or remove sites. So as and when required, you can do it, and enhance security through the use of IKEv2 and the support for multiple access methods, including any-to-any connectivity. All these things are there in the FlexVPN. Furthermore, FlexVPN simplified configuration and management reduce operational overhead typically associated with traditional VPN solutions. Now, let's go back to the DMVPN. That is the main part. How to configure the DMVPN. Now, setting up DMVPN typically involves several key aspects. Like, first, configure the hub router with a public IP address and establish the necessary routing protocols. Means there are two addresses. One is the NBMA, non-broadcast multiple access. That is the public IP address you are having, say on the say serial port, and you are having say the tunnel interface IP, that is on the tunnel interface, GRE tunnel. Second, configure the spoke routers to establish GRE tunnels towards the hub router. Then, followed by enabling NHRP for dynamic address resolution. So what does NHRP do? They actually dynamically resolve the address between the NBMA and the tunnel. So there are two addresses. They are resolved mutually. Lastly, apply appropriate security measures of protocol, including IPsec encryption, actually to ensure secure data transmission. So advanced DMVPN features include support for various topologies such as spoke-to-spoke communication without requiring traffic to route through the hub that I was talking about. That first, the traffic is routed through the hub. That is the first type. Then it doesn't require. The traffic can move fastly between the spokes without the intervention of the hub. Other features incorporate route redistribution, which enables seamless integration with other routing protocols, and support for VRF, virtual routing and forwarding, to share the routing tables into different parts, as you know, to allow multiple customers or divisions to share the same infrastructure securely. So this is the topology you can say that will understand the better of the DMVPN. Like you are having the hub router, which is having two IP addresses. One is the 192.168.123.1. That is the gigabit port, or it is using the gigabit Ethernet port in case of the say serial port. It is the NBMA address. And the spoke router is using spoke 1 is 123.2, and the spoke 2 is using 123.3. These are all the NBMA address part. And now, in case of tunnel, you can see the tunnel is using, like the .1 interface is 172.16.123, say 1, and that spoke is 2, and the spoke 2 is 3. So that is the tunnel interface. So there we are having two type of IP addresses. So now I can show you some say configurations of the hub router. As you can see, in the hub router, you have to configure this actually in your simulator, like the GNS or EVE-NG, because packet tracer doesn't support this DMVPN fully. So you have to go to the hub router, you have to configure the interfaces IPs, also the tunnel IP. But apart from that, you have to give this command. Let's understand that. Tunnel mode GRE multipoint. You are going to the tunnel interface and you are giving the command tunnel mode GRE space multipoint. What does it mean? It means that your tunnel, GRE tunnel, it is having the point to multipoint connectivity, because as you see, it is like the frame relay network. So it is having the point to multipoint, multiple sites are connected. Then tunnel source, you have to give the physical interface that is having the NBMA address number. So gigabit port or Ethernet port or serial. Then IP and HRP authentication, it is optional. You can give the key. In that case, you have to give the same key on the hub as well as on the spokes. But you can omit that. IP and HRP map multicast dynamic. What does it mean? It means that it dynamically or automatically maps the NBMA addresses of the spoke router with the tunnel IP address. So it dynamically maps those two. That is very important. Then IP and HRP network ID 1, that is optional. You can give it. But yes, if you give it, it should be same on hub and spokes as well. Then in the spoke, say you're having spoke 1, you can have spoke 2 also. So only the IP address will change. In the spoke 1, you are having tunnel 0 interface IP address is 170.160.120.2. That is the tunnel IP. Then IP and HIP authentications, DMVPN, so the key should be same. It is, again, it's an optional. Then IP and HIP map. This is the very important part. You are mapping the tunnel interface IP 172.16 to the NBMA 192.168. You are doing the map. And in this case, the NHRP, next hop resolution protocol, will be used. Then the IP and HRP map multicast. Then you are giving the, say, the NBMA address. So you are actually doing a multicast mapping with the NBMA address, not the tunnel IP. This is very important. And then the IP and HRP network ID, the same network ID if you give. And then you specify the IP and HRP NHS. That is the NHS next hop server. What is the next hop server? Who is that? That is a hub router helper. And you have to give the NBMA address, not the tunnel interface. And then the tunnel source, you have to specify always the tunnel source, that will be the gigabit. Tunnel destination will be, again, the, you can say it would be the, again, the NBMA address, but in case of IP and HFP NHS, it would be the tunnel IP address. So this is the configuration that already it is running. I can show you, it is in the GNS simulator. And if you say you see the configurations here, it is already configured, but I have already used this. But in case of the gigabit port, I have used the fast Ethernet port. You can see the IP address here. You can see the tunnel interface also. It is having the IP address 172.16.0.1 here I'm using, and I'm using tunnel mode GRE multipoint, and tunnel source is faster than 0 that is having the NBMA address and IP and HRP map multicast dynamic. Now go to the spoke routers. As you have seen, I've configured 2 spoke routers. These are 2 spokes. So let's go to the R2, and you can see the configurations up there. That you can see that I have given the IP address in the first Ethernet port as the NBMA address 192.168.0.2 and tunnel interface 172.16.0.2, and then I'm mapping IP and HRP map with the tunnel interface to the NBMA, and just a typo here, but now you see that IP and HRP map multicast, and I'm giving the NBMA address, and then the IP and HRP NHS and the tunnel interface, tunnel source, the first Ethernet, and the tunnel destination is the, again, the NBMA address. Only the IP and HRP NHS should be the tunnel interface. And like that, in case of the router 3 also that is running here, I have configured the same thing, but only the IP address is different. The fast Ethernet port is having the NBMA 192.168.0.3, tunnel interface is having 172.16.0.3, that is tunnel IP. You are creating a static map with the IP and HRP map statement with the 172.16.0.1, that is the tunnel IP of the R1 with the NBMA IP, and then the IP and HRP map multicast, you are giving the, you can say, the NBMA address, then the IP and HRP NHS, you are specifying the tunnel IP. Again, the source should be the fast Ethernet here on this router, and the destination will be again the NBMA. So here you can see that if I configure this, and if I go to the R1 to check the DMVPN configurations, now you can see that it is showing. If you give this command show DMVPN at last, then you just see the peers, that is the clients, that is the 192.168.0.2, and the, say, you can see also the tunnel IP, the mapping, and the 192.168.0.3 and the mapping of the 172.16.0.3. So that is the tunnel that is created, and you can see the clients. And if you go to the, say, the spokes, and now if you give your show IP NHRP, you can see the entire configuration. Like this is the tunnel IP, and the tunnel is created. So NBMA address you can see. You can also give this show DMVPN on the clients as well, and you can see the NBMA as well as the tunnel IP of the NHS of the hub router. Also, alternatively, you can go to the R3 spoke, and you can also see here that you have got the show DMVPN. If you do that, then definitely you can see the hub router's NBMA address with the mapping with the tunnel IP. And also, if you give show IP and HIP, it will also show you the same thing, but in a precise way. So what it is done that you can actually communicate directly. Actually, you can communicate directly with the, say, if I want to communicate with the, you can ping the 192.168 and say 0.2, then definitely the router is communicating, but it is taking some latency. And now, if you give trace route to the say the 192.168.0.2, you can see that it is going directly. Just see that it is not going to the hub route. It is not going to the 192.168.0.1. It is from the R3. It is going straight to the R2. You can say it is going in the hop one, means it's taking one hop. This is the advantage of the DMVPN, that it builds actually the point-to-point Jerry tunnel between the spoke routers without the intervention of the hub router. So you can see clearly that in the trace route, if you trace that traffic, that it is not following the hub router path, but it is taking the spoke-to-spoke communication. So that is about the, you can say, the power of the DMVPN, that in the traditional VPN, the latency is high because your traffic is always passing to the hub router, that is the ISP router. And definitely, if you implement the QoS there, then there is a solution. But apart from that, definitely some latency should be there. Again, DMVPN has different parts also, like phase one. Then it has a phase two, where it builds the dynamic tunnels, and also the NHRP, NHS. They actually register, the spoke routers register with the NHS. So there are certain messages are exchanged between them. It is a complex and lengthy process. And also the DMVPN phase 3, where you are using the summarization, actually the feature. So these are the different steps that is, I will discuss it more detail in some other day. But this is about the overview of the DMVPN, you can say. And as you know, the DMVPN is also a very big technology, and FlexVPN is also a technology like the DMVPN, you can say. But DMVPN is used more, and it is definitely in the CCNP Enterprise, as well as the CCNP Security and CCI studies. Also, in the case of the CCNA, also in the case of 200301, DMVPN configuration may not be there, but the theory part is there. And if you do the configuration, then it will be an added advantage for you for your studies for the CCNA, as well as in the any level of certification. And also, it is very important for as a network engineer for your job prospect as well. So as you know, the DMVPN or any type of VPN is the future of the WAN technology, because the lease line or the frame relay, that is an obsolete technology, like the frame relay, ISDN is not used. Only the lease circuits are there and one or two parts. But definitely VPN, virtual private network, it is the dominant technology in the WAN market nowadays. So I think definitely you have to know this and use this technology to a great extent. And it is definitely useful for your studies, for your Cisco certifications, and also for your job prospect. So that is all I have for now today about the VPN, the DMVPN and FlexVPN technologies for Cisco. And I've discussed the salient points of these technologies, and also I've shown you the practically how to configure the DMVPN. That is only the basic configuration. Then after that, you can also configure the routing protocols like the RIP. RIP is not used nowadays so much, so you can configure OSPF, EIGRP, or BGP. That is the additional part in the phase 2 and phase 3. But I have only shown you the phase 1 for now. So I hope that you have got good knowledge about these two technologies, DMVPN and FlexVPN, about this webinar. And we will also be able to incorporate this in your corporate environment. Also, it will help you immensely in your Cisco studies. So that is it for today. And I thank you all for joining and watching this webinar once again. I will come with a new topic next day. Till then, keep studying and bye.